Hello again, this is Ife Martins, and we are still on this issue of indices. In previous videos, we talked about how exponents are just the concept of repeated multiplication. We talked about the rules of indices. Okay, a raised to power 0 equals 1, which means any number raised to power 0 is always 1, regardless of the value. Okay, no matter how big it is, don't think 1 million raised to power 0 will be something meaningful. Okay, moving on. A raised to power m times a raised to power n equals a raised to power m plus n. Okay, a raised to power m divided by a raised to power n equals a raised to power m minus n. Then D, the green rule. A raised to power m, then everything in bracket raised to power n is equal to a raised to power mn, which means you just multiply the inner index with the outer index. Okay, m in the inner index here and n the outer index. Now let's go into something more serious, okay, which I hope you understand. Of course, do you even have a choice? Okay, we'll call it E, and it has an attractive color. This is one of the rules that actually discourage people from indices. Take a look at this very carefully. It says a raised to power minus m is the same thing as 1 over a raised to power m. I'm confused. Don't be, okay? Don't be confused. Maybe you're just looking like this guy now, hands in the air, say, Tuali Babao, what's this? Oh? And you have somebody assuring you that there's nothing to worry about. Guy, just calm down. Maybe, hi, ordinary indices, and you are here frowning when somebody already understands the concept. Okay, too late. Anyway, the whole idea, take a look at this. Don't look at the a minus m thing too much. Just see it this way that if our guy here, okay, let's call it a, big boy, is raised to power minus 2, for example, it means you see this minus, the best way to look at it is just convert it as if you are rotating it to stand. Okay, something that was lying down like this, JJ, you want to turn it over, okay, to make it stand. So if this minus becomes standing, what will happen to it? It will become 1 like this, divided by, if this one stands on it, you have a squared. This is very tricky, but pay attention very well, okay? Now, this is a negative sign, okay? Let's do something. Let's say 4 raised to power minus 3, okay? Since this is negative 3, let's try and see negative values as something negative, just for the sake of this example. That we want to get rid of this minus because we don't like it. It confuses us. So this horizontal line that is moving from left to right, let's convert it to one that will stand if it will stop all our negativity. So what do you do first? You convert the minus to a standing one. Okay, that means you are flipping it. Then now it has to be king over what? That your same base that is big, but this time around 4 raised to power 3. So the idea behind it is to remove the what is it called? To remove the negative sign, you may actually just need to bribe it. What do I mean bribe it? Again, I'll show you another example so you understand it quite well. If you have x, since you're always avoiding x raised to power minus 4, what is the first thing you should do? I said this negative sign, okay, this negative here, convert it to 1. Okay, it's called the reciprocal. Okay, 1 divided by x still stays, then it's still raised to power 4, only that this time, instead of negative 4, it has been converted to 1 over x raised to power 4. Okay, that's how you solve that. So in a way, it's just something as saying 10 raised to power minus 1 is equal to 1 over 10. Get familiar with these figures. Also, 6 raised to power minus 2 is the same thing as 1 over 6 raised to power 2. Okay, now, why is this one not raised to power anything? Because if you put 10 raised to power minus 1 it is still correct, but it doesn't affect the value. 10 raised to power 1 is 10. Okay. So if you have, say, 15 raised to power minus 6, what do you do? Take away the negativity, flip the negative sign to 1 over, what do you have? The 15 still stays, okay? The index still remains 6, only that is no longer negative because that negativity has been paid for by us turning this into a fraction. It's going to take a while for it to sink in, but I assure you, once you can remember all these rules, okay, you'll be fine. Wow, wow, all right. I can promise you that. At the risk of sounding like a broken record, let's go over the idea again. Okay, it's quite confusing if you're not very careful. It says a raised to power minus m is equal to 1 over a raised to power m. Now let's leave all this. Yeah. Let's do something real. If you are told to evaluate 2 raised to power minus 3, okay, it's just for you to say, what do? You change the negativity. You cast out all the spirit of negativity. Negativity, I bind you. Negativity, turn to 1. Negativity, I bind you. This year is my year of positivity. This year is my year of positivity. No negativity shall stand in my mathematics textbook. Okay, something like that. I'm sorry. Well, 1 over 2 cubed. Okay, so you can now pretend we are back to our normal indices. This is 1 divided by what? 2 times 2 times 2. Okay, so 2 times 2, that's 4. 4 times 2, 8. So this is 1 over 8. Okay, so 2 raised to power minus 3 is equal to 1 over 8. Well, let me test your mathematical reasoning. Can you tell us another way of writing this 1 over 8? I mean, if someone gives you write 1 over 8 another way other than 2 raised to power minus 3, how would you approach that? Well, what I can do is, since this guy is feeling like one positive guy all around, I can just say it's the same thing as 8 raised to power minus 1. How do I know? Because this positivity is smiling about, I want to flip it back. So if this was the original question and you're asked to show what it means negativity out of my life. What do you do to negativity? You convert it to the reciprocal, okay? 1 over 8 raised to power. Of course, I told you the power still stays. Only that the power is 1 and anything raised to power 1 is that thing. So we still have 1 over 8. Okay, so let's move to the final law. We will explain this concept further when we get to worked examples. Okay, so let's move on to the last law, which is the law, the sixth rule of indices. Okay, let's have F here. Now, pay strict attention here. This one says if you have a raised to power m divided by n, people are just wicked. I don't know why you would want to do something like this. I mean, look at m and n just playing on their own, and then all of a sudden we start dividing them. So how do you approach this? Well, the idea is that let's clean this off. Okay, so we can have space to work. Oops, sorry about that. Tampered with our law. Okay, moving on. So, it means if you have this a raised to power m divided by n. Oh, excuse me, that was a mistake. All right, now we're fine. A raised to power m minus n equal to n root a. When you have this, then everything raised to power m. Let me rewrite that here. A raised to power m over n is the same thing as n root a, then everything raised to power m. Okay, so the idea is that you see the denominator. The denominator is the one under the fraction. Okay, you have numerator all over denominator, okay? Numerator over denominator. So the idea is that if you have m raised to power n, it means you do n roots the base, which is the a here, everything raised to m. Let's quickly have an example. If you have 125, 125 raised to power 2 over 3, okay? Our a is 125, then our m is 2, our n is 3. What we are saying is 3 roots a raised to power what? Raised to power m squared. Okay. But our a here, as you know, is of course 125. Sorry about that. That was a. I shouldn't be using the letters again since I know you don't like them and it's an example. So that's equal to okay. Now we can go on, which is equal to, sorry for the technical problem, 3 root 125 raised to power 2. Okay, what it means is what number will you have to multiply by itself 3 times to get 125? Well, that number happens to be 5. Okay, so your answer is 5, but then don't forget the square outside. That's what gives you the eventual answer, which is what? 25. I know this is not clear, so I'll give you something that will make it clear now. Okay, you've heard of people say something like square root, square root, square root. Technically, if you want to do square root, okay, what is square? I told you a square, as in, you remember our celebrity indices, okay? Remember cube root, okay? X squared, x cubed. Those are the celebrity indices. So if someone tells you to find the square root, it means what will be multiplied by itself twice to give you the same number. So square root of 9 will be 3 because it is 3 times 3 that gives us 9. So, but essentially, square root of 9 is actually an invisible 2 root 9. Square root. Remember, square root. Okay, so what's happening in essence is if you cannot write square root of 9 the usual way of root 9 like this, another way of doing it is to say 9 raised to power half. Please pay attention. 9 raised to power half, because if you have 9 raised to power half, okay, it means following this rule, it will be 2 root 9, okay, then everything raised to power 1. Take a look at it again. 2 root 9, then raised to power 1. So if you have an example like, say, okay, we already did that of 125, but let's go over the letters again. If you have x raised to power I over j, it's the same thing as saying j root x, everything raised to power I. Whatever confusions you are having now, I assure you they will be clarified when we do the worked examples part of the whole thing. But just know that, think of square root as x raised to power half, okay, without having 2 root x itself, then raised to power 1. Let that idea sink in. Pause the video, look at it again. Once we do examples, it will be clear to you. See you in the worked examples version. This concludes all the rules of indices. This is Ife Martins. I'll see you in the next video.